We are going to discuss one important topic of a famous topic of system design, which is scaling. Scaling means if your system is getting a high input load at the time, by the time, then your system might should get handle all those inputs or all those loads. The scaling we have are two types: horizontal scaling and the vertical scaling. Vertical scaling is something, for example, if your current system, if you have a system and your system is right now using a server which has a configuration of 8 cores, 16 GB RAM and 512 GB hard drive memory. But yeah, for some reason, if you are get extra input load or extra heavy load on your server, then what you can do, you can just simply increase the server. Well, like you can just simply change the configurations. You can just increase the configurations. That is the vertical scaling you are doing manually. But what are the benefits and advantages and disadvantage for this one? The advantage is it is very simple. You just have to manually change the configurations like RAM, processors, whatever you are going to change. The disadvantage is it's very expensive, and of course it's again a very limited scaling, because right now in this example you are using 8 cores. Now in this you are using 16 cores, but for later in future, if you get a multiple bunch of millions of users as well, then your 16 core will definitely not going to work. Then you have to move it to the maybe 32, 62, 64. It depends on the requirements. So that's why we have an alternate option, which is horizontal scaling. A vertical scaling is good if you are not scaling that much. If you don't have that much audience, then you can use horizontal scaling. Horizontal scaling is just have to increase the machines. Just look at in this architecture, you can clearly understand. Here you can see this is the load balancer, and these are the servers, and the load balancer will decide on which server your request will go. If you don't aware of load balancer, you can check out my new video, like my previous video, sorry, and link in the description. The load balancer will decide on which request on which server the request will be get. If for some reason, if the server will get faulty tolerance, it means it's a very advantage of this one. It's a fault tolerance. If your one server might get breakdown for some reason, then there are another server which get handle those applications, like your current system application. So that's why the advantage of this is it's very effective, and it's very scalable. And the disadvantage is it's very complex distributed architecture system. Thanks.